Completing the square is a process that we can use to help us solve some quadratic equations. See, when we have a perfect square quadratic, like x plus 7 squared equals 25, how we'd go about solving it is by square rooting both sides. Then we'll be left with x plus 7 is equal to plus or minus the square root of 25, which is 5. The last thing to do then is just subtract 7 from both sides. And so x equals negative 7 plus or minus 5, which negative 7 plus 5, or negative 7 minus 5. Negative 7 plus 5 is negative 2, and negative 7 minus 5 is negative 12. And so those would be our two solutions for x. When we talk about the square, we're talking about the square of the binomial, the x plus 4 squared. Now, we FOIL it all out, and we know that that is going to equal x squared plus 8x plus 16. But I want to draw you a picture. This is a picture of a square. And the thing about this square is that the length of from here to here on this side is going to be x. And the length from here to the end is 4, making the entire length of the side x plus 4. Since it's a square, the other side is the same, where this length would be x, and this length to the bottom then would be 4. So this is x plus 4 as well. That means that I've divided this bigger square into a couple of regions. We can find the area of the big square by looking at the sum of the smaller pieces. First of all, this square right here is x by x, making it have an area of x squared. When we get to this one on the side, it's 4 by x, making it 4x, and so is this one. That's 4x as well. The last piece is 4 by 4, making it 16. So when we add all of this up, we get our x squared. 4x plus 4x makes 8x, and we're left with 16, which is the sum that we wanted. When you're asked to complete the square, we're asked to find a number right here, some constant number that I can add to this polynomial to make it a perfect square. Let me draw you that picture again. When we have our square like this, remember that it was this number, or that area, that gave us the first term, that x squared term. Which means this square would have to be x by x units on each side. The middle term came from adding up these two. So the sum of these two areas had to be 2x, which means I got to take that 2x and split it in equal pieces, making this side 1x and this one 1x as well. What we want to do is to complete the square, which means find out what number this should be. Well, the thing is, going back just one step, since I know that the area of this rectangle is 1x and the length of this side is already x, well, just from deduction, that means that this side has to be 1. So the entire length of the top has to be x plus 1. Since it's a square, this side would have to be x plus 1 as well. And wouldn't you know, since this side is 1 and this side is x, that makes the area of this rectangle 1x. So we've completed the square, except we haven't actually filled in this missing area yet. And that's going to have a side of length 1 and 1, so 1 times 1 is 1. In order to complete the square, this number would have to be 1. And it would make the perfect square of x plus 1 squared. X plus 1 times x plus 1. Of course, we should be able to do this a lot quicker without having to draw a square every time. And how we do that is pretty direct. What we do is we take this 6x, and remember it's got to be split up between those two rectangles. So what we do is we take it and divide it by 2. Then square it. 6 divided by 2 is 3. 3 squared is 9. That's going to give us the perfect square of x plus 3 squared. For negative 10x, first of all, divide it by 2 and then square it. So negative 10 divided by 2 is negative 5. Squared is 25. This will give us a perfect square of x minus 5 squared. Notice that this one was minus 5 because this was minus 5. Right? The one on top was x plus 3 because this was plus 3. When we have an odd number, it seems trickier, but it's not. We're going to do the same thing. Divide that by 2 and then square it. So 3 divided by 2 is 3 halves. When we square it, we get 9 over 4. Its perfect square is going to be x plus something squared. What that something should be is right here. So x plus 3 halves squared. And that's how we complete the square. How do we use completing the square now to help us solve? And in order to do that, the first step is to get this constant term off to the other side. Then we'll be left with x squared plus 6x equals 27. And what I'm going to do on the left hand side here is complete the square by adding some amount. So once again we think half of this is 3. When we square it we get 9. Now I've changed the equation by adding 9 to the left hand side. And one thing we know about solving equations, if we do something to one side, we got to do it to the other. So I just added 9 to the left hand side. I should add 9 to the right hand side as well. On the left, by adding 9, we've created this perfect square, x plus 3 squared. On the right hand side, 27 plus 9 is 36. Now we're back to that same problem, a similar problem that we started with, and we solve that by square rooting both sides. X plus 3 is equal to plus or minus 6, and then subtract 3 from both sides. X equals negative 3 plus or minus 6. Negative 3 plus 6 is 3. Negative 3 minus 6 is negative 9. And those are our two solutions. Let's do it again. X squared minus 10x equals 24. This time, that 24 is already over there, so we can just jump right into completing the square. Take half of that negative 10, negative 5, and square it. 25. Whatever you do to one side, do it to the other. We've just created a perfect square over here, x minus 5 squared. And on the right hand side, that adds up to 49. Now we'll just go through and solve it. Square root both sides. And that leaves us with plus or minus 7. Add 5 to both sides. 5 plus or minus 7. 5 plus 7 is 12. 5 minus 7 is negative 2. So these are our two solutions. One more. X squared plus 12x plus 4 equals 0. Get that 4 on the other side. We're left with x squared plus 12x equals negative 4. Complete the square. In order to do that, we take half of 12, which is 6, and square it. 6 squared is 36. I just added 36 to the left, so add 36 to the right. We just made the perfect square over here of x plus 6 squared, and on the right hand side we're left with 32. Now it's just solving. Square root both sides, and we're left with plus or minus the square root of 32. Well, 32, I remember, is 16 times 2. So that's the same as plus or minus 4 root 2. Right. Finish it off by subtracting 6 from both sides, and we get negative 6 plus or minus 4 root 2. Now we can't combine those two. Like negative 6 plus 4 root 2 does not make negative 2 root 2. So don't do any of that stuff. Since we have one term that's an integer and the next term is irrational, just leave it like this, as negative 6 plus 4 root 2 and negative 6 minus 4 root 2. And we can even just keep it simplified like this, as negative 6 plus or minus 4 root 2.